Hello everyone. This is the second video in your Unit 2 Linear Equations unit. What I'll be covering today is the material that the pre-class assignments solve for a variable and graph to solve systems cover, which are listed right here in your homework, and the post-class assignment systems of linear equations. Notice it has a prereq of these two post-class assignments. So this video will cover these three assignments. Then you notice I'll make one more video tomorrow that will cover these assignments, and you guys will have all the material ready for the exam. The exam is not due till 6/29, but you should get it done as soon as possible, as the next assignments will be due that following Thursday after 6/29 on 7/3. 7/4, July 4th is a holiday, that's a Friday. So I decided not to make anything due over that weekend, so I made these assignments due by Thursday. And then I have the test due by Sunday night after 4th of July. So really, if you get on it, you could get all this stuff done before your 4th of July holiday. Then after 4th of July, come back and worry about the last unit. Okay? So let's go along. Okay. So you had two pre-class assignments. Make sure you do both of those before you watch this video. Now let's move on. Consider two lines written in standard form, ax plus by equals c. That is just a standard form of how to write a linear equation. You know, I could move the c over and have it equal to 0. I could write it in a bunch of different ways. This is a good way to set up your equations to help us solve the systems, but you don't necessarily have to. Any line written in standard form can be written in slope-intercept form, basically taking this equation and solving for y by moving this over, the a times x, and then dividing by b. Note that capital B and lowercase b are not the same value. This b is a constant, so it kind of relates to the c variable in this case. All right? The b is the coefficient on y, where here the coefficient on y is just 1. So capital B and lowercase b are not the same variables. All right? So here's a system of equations. Basically what it is two linear equations that the solution to this system is where these two lines cross. And you can see here from the graph that these two lines cross at one and only one point. Remember, if you have straight lines, two straight lines, only three things can happen. They can either be parallel and never cross. They can be one on top of each other and cross at every point, or they could be this example here, which is most of linear systems, where they have one and only one solution. Notice they won't have two solutions because this line isn't going to curve back and cross over again, right? It's not a parabola, it is a line, so it's only going to have one solution. So let's go ahead and plot this point. So this is 1, 2, 3, 4, 1, 2. This is the point 4, 2. So when x is 4 and when y is 2, that satisfies both of these equations. That makes both of these equations true. Okay? So first let's write each line in slope-intercept form. So basically I'm going to solve each one for y. So let's take this one first. So I have 3x minus 4y equals 4. First thing I'm going to do is subtract 3x from both sides. And that means that now I have 4 negative 4y equals 4 minus 3x, and then I'm going to divide. I'm going to switch the order of those two because we like to write our x variable first, so I'm going to write this as negative 3x plus 4. Okay? Make that 4 prettier. Then I'm going to divide both sides by negative 4. Every term is getting divided by negative 4. Really, I could write one line and write negative 400, but this really helps you to see that everything is being divided by negative 4. So my first equation is y equals negative 3 divided by negative 4 is positive 3/4 x minus 1. 4 over negative 4 is negative 1. Notice that 3x over 4 is equivalent to 3/4 x. But I like writing it in this way because it makes it simpler to pick the slope out. The rise is 3, the run is 4. But these two things, if you see them written like this, they are the same thing. This x is in the numerator, even though it's not explicitly written there. Okay, so there's one of my equations. So So I'm going to go in here and put a little set notation bracket and write this equation. Y equals 3/4 x minus 1. Okay, now I'm going to erase this work so that I can solve this other one for y. I'm going to do it right here in the same place. If I went a little too fast right here, pause the video and write down the steps that I used. All right, let's erase that. Now let's solve this other equation. So let's consider this one. So I have x plus 2y equals 8. I need to solve for y, so I need to subtract x from both sides. That implies that 2y, once again I'm going to write the x first because it's written first in our slope-intercept form, as negative x plus 8, and then divide by 2. And that implies that y equals negative x over 2 is the same thing as negative 1/2 x plus 4. 8 divided by 2 is 4. So there's my two equations. Y equals negative 1/2 x plus 4. So the y-intercept of our first line, let's call this equation 1. Let's call this equation 2. So equation 1 has a y-intercept of negative 1, and it has a positive slope, 3 to 4. So that's this line. Look, it crosses at negative 1 and it goes up 1, 2, 3, and over 4. 1, 2, 3, 4. So this is equation 1. That's the line that corresponds to equation 1. And then equation 2 should have a y-intercept at positive 4, which it does, and then have a negative slope, minus 1. So fall 1, run 2. So we fall 1 and run 2. And notice it goes through that point. Fall 1, run 2. It goes through that point. Fall 1, run 2 goes through that point. Fall 1, run 2 goes through that point. So this is equation 2. Okay. So identify which line goes with which equation and label them. So we've done that. The solutions to the system are the ordered pairs x, y that satisfy both equations at the same time. Which this is the only point in this entire plane that would satisfy both lines, right? If I picked this point would satisfy line 2, but it would not satisfy line 1. Okay. Graphically, we are looking for the points of intersection between the two graph lines. Check your answer by substituting into the two equations. So I'm going to take this number, this ordered pair, and substitute it into my equations and see if it gives me a true statement. So let's take equation 1. So equation 1 is y equals 3/4 x minus 1. Let's double check, make sure I did that. I wrote it correctly. 3/4 x minus 1. Okay. So now I'm going to substitute. So I'm going to let x equal 4 and y equal 2, which is the ordered pair 4, 2. So now I'm going to come over here and I'm going to plug in for y. I'm going to plug in 2. So this implies, and I'll put parentheses around it to show that I evaluated. 3/4 x, I'm going to plug in 4 minus 1. Okay. So now, so there's that. This little arrow just means it came from the previous line. Same from this arrow. So the information that's here came from the previous line. So then I have 2 equals 3/4 times 4, that goes away, and I'm just left with 3. 3 minus 1 is 2. So it does satisfy that equation. When I say satisfy, satisfy means makes a true statement. That's what satisfies means. And 2 equals 2 is a true statement. If I would have got 2 equals 1, that is not a true statement, so it doesn't satisfy that equation. Okay, so we know it satisfies equation 1. Let's try it for equation 2. I'm really just going to do this because I'm going to still let x be 4 and let y be 2. But now my equation's changed. It is negative 1/2 x plus 4. So I have negative 1/2 x plus 4. Let x be 4 and let y be 2. So that implies that 2 equals negative 1/2 times 4 plus 4. So that implies that 2 equals negative 1/2 times 4. So 2 goes into 4 twice. Negative 1 times 2 is negative 2 plus 4. which is equal to positive 2. So it does, in fact, check out. So the point 4, comma 2 satisfies both of these equations. So therefore, it is the solution to the system. This is one way to solve systems of equations. One is by graphing. One is by, we'll see, called substitution, and another one is called elimination. Basically, elimination is where we add the two equations together to get some kind of canceling. We rarely will use graphing for this because we could have a case where two lines cross here in the middle of points, right? This is not an integer. So this is just one example. What if I have two lines that cross in the middle of a space? How do I find that number? Well, that's where we use our other algebraic methods. So solving solutions by graphing is usually a last resort. You would try the other two methods first. Okay? Now here we go. So if I look at these two lines, just by looking at the graph, it looks like they're parallel. Parallel means they run next to each other and never touch. So if they never touch, there's never going to be a solution to this system. But how do I know it? Maybe if I didn't have this graph, how would I know that these equations are parallel lines? Well, first, let's put them in slope-intercept form. So let's consider this one first. So 4x plus 6y equals 12. So I'm going to move the negative 4x over. So it becomes 6y equals negative 4x plus 12. And I'm going to divide both sides by 6. And that implies that y equals, negative 4/6 is negative 2/3 when you reduce it, plus 2. So my slope of this line, of one of the lines, is negative 2/3 x plus 2. So equation 1 is y equals negative 2/3 x plus 2. So this line goes through negative 2, this line goes through positive 2 at the y-intercept. So this is my equation 1. And fall 2, run 3, right? Fall 2, run 3. So it does map that line. Now let's do the other one. All right, let's move this one over. So I'm going to move the 2x over so it becomes negative. So then I have 3y equals negative 2x minus 6. Divide everything by 3. That implies that y equals, this is an arrow even though it doesn't look like it, y equals negative 2/3 x minus 2. Now you notice equation 2 has a negative y-intercept. Y equals negative 2/3 x minus 2. So these two lines have the same slope but different y-intercepts. So this is equation 2. That's how I know two lines are parallel, if their slopes are equal. What do you notice about the graph of two lines? They are parallel. P-A-R-A-L-L-E-L. Algebraically, what that means, when two lines are parallel, a synonymous statement to saying two lines are parallel is that they have equal slopes, right? Which is the variable m, right? M is slope. That's how I know two lines are parallel, is they have equal slopes. These two statements are interchangeable. Parallel means they have equal slopes. If they have equal slopes, then they are parallel. And notice if they have equal slopes and equal y-intercepts, then they're just the same line. They have an infinite amount of solutions, which is what this next formula shows. So if I solve these two things for y, so let's take the first one. Negative 3y equals negative 2x minus 6. Divide both sides by negative 3. That implies that y equals, now negative over negative means it's a positive. plus 2. So my equation 1 is y equals 2/3 x plus 2. Now let's do my other one. Equation 2, right here. So I got 3/2 y equals x plus 3. Because when I move this x over, it becomes positive. So I'm going to multiply both sides by the reciprocal, by 2/3. So both of these values are getting multiplied by 2/3. I have to distribute this 2/3. So that becomes 2/3 times 3/2 is 1. So we have y equals 2/3 x. 3 times 2/3, the 3's cancel, and I'm just left with plus 2. Notice that these two lines are the same thing. They have equal slopes and equal intercepts. So when they're parallel, they have no solutions. And when they're on top of each other, they have infinite, which this is the sign for infinity, infinite solutions. So systems of equations can have one of three outcomes. Can have one solution, no solutions, or infinite solutions. It can't have two, it can't have three. It's either one, none, or infinite. What do you notice about the graph of the two lines? They are the same. What do the graphs tell you about the two equations we started with? They are equal. Now let's think about it. What if I had two lines with different slopes, but the same y-intercept? So different slopes, but the same y-intercept. We would essentially just have a regular solution. Think about if this point was moved over to the y-intercept. So that's fine. They can have different slopes in the same y-intercept. The y-intercept is just the solution to the system. So the slope is the most important, and then we look at the y-intercept. Okay, generalize. What you know about the solution to a system of two linear equations and two unknowns. How do we know if an ordered pair is a solution to the linear system? It satisfies or makes the statement true. It satisfies both. That's very important. Both equations. When solving a linear system, what are the possible outcomes? No solutions, one solution, and infinite solutions. So when there's no solutions, that means they have equal slopes. And then infinite solutions is equal equations. We'll say everything's equal. The equations are equal. And then one solution is just other. Right? One solution, we would say different slopes, because the y-intercepts can be the same. Okay? So either the slopes are equal, the entire equations are equal, or if neither is the case, then you have a regular system with one solution. When the equations are in slope-intercept form, how can you tell what form the solutions will have? So basically, that's this parentheses right here, answers question 3. If the m's are equal, there's no solution. If the entire equations are equal, there's infinite solutions. And if the slopes aren't equal, there's only one solution. Notice here, we don't care about the y-intercept. So the slope is the most important thing. Now, here is an example that I started the video with where the solution to this equation, to this system, doesn't fall on a whole number, right? Or on an integer. It falls in between -8 and -9, and it falls in between 3 and 4. So we can't really guess that. So in this case, solving by graphing would not be the way you want to do it. Okay? So I'm not really worried about writing a solution in slope-intercept form. Before graphing, what do you know about the solution? It has a solution, but they are non-integer. Okay? Can you visually determine the solution? No, we can't. What is the disadvantage of using the graphical method to solve a system of linear equations? If the solution is not an integer. And in most cases, the solution is not an integer. When you get out into the real world, the solution of these type of problems is a decimal most of the time. It is not a whole number. So that's why we will learn these other methods for solving systems of equations. Okay? So there's two other methods for doing it. There's algebraic strategies for solving a system of linear equations. We can either solve by substitution or we can solve by elimination, which is like adding the two equations together. Now, I'm not really going to write out the steps yet. I want to go through some examples, and then we'll come back to this page and write the steps out. Now, I will say, which method you choose is either a matter of preference. Maybe you like one method more than the other one, so you just stick with that method. That's fine. I like to choose whichever one is going to be the easiest, whichever one is going to make me have the least amount of work. Now, I know that sounds counterintuitive that a mathematician wants to do something that's going to be the easiest, but in fact, that's what we do. We try to find the easiest method for solving. Okay, so let's solve using both algebraic methods, substitution and elimination. So this one I'm going to solve by substitution. And maybe you can understand why after I solve it. Substitution is pretty easily in the fact that we solve by substituting. So it's kind of self-explanatory. The first thing you need to do this is solve one equation for either, it doesn't matter which variable, I would pick the easier one, for either variable. Notice I pick substitution for this one because this second equation has already been solved for a variable. So my step one's already done. That goes into choosing which method I would use to graph this. Then plug back in, B-A-C-K, excuse me. Plug back in to the other equation. It's very important that you plug it into the other equation. If you plug it back into the same equation, you will just basically do a circular type thing. So step one is done. We've already solved this for x. Now I'm going to do step two. I'm going to plug this value for x, this -2y plus 8, I'm going to plug it in right there for x. Because I know x is equivalent to this statement. So I still have my 2, I can't forget about it. -2y plus 8 minus 3y equals 2. So now notice I have an equation with only one variable. I can solve this equation. Solve for remaining, and there should only be one variable. Okay, so the first step to solve this is I have to distribute this 2. So that implies that, so I'm still doing, or now I'm actually doing step 3, right? I'm solving. So I get -4y plus 16 minus 3y equals 2. I'm going to subtract 16, and I'm going to combine these two like terms. So that implies that -7y equals -14, which implies that y equals, when I divide both sides by -7, I get +2. So now y equals 2. Now plug back in to find other solution. All right. So these 4 steps are basically what goes right here on the previous page. So if you want to rewrite it, now's a good time to rewrite it. And it's good to rewrite it so that you learn, so that you remember these steps. Because the more time you write something down, the more chance you have of committing it to your long-term memory. So now I'm going to plug this value, y equals 2, back in to right here. So that implies that x equals -2 times 2 plus 8, which equals -4 plus 8, which equals 4. So my solutions are x equals 2, or y equals 2, x equals 4, or you can write it in order pair 4, 2. Okay? And then step 5 is to check. And of course you always want to check your work. So 4, 2, I know 4, 2 works when I come back in here, right? Because when I plug in 2 for y, I got 4. So I know it satisfies the first equation. Let's plug it into the other one. So this means 2 times 4 minus 3 times 2 equals 2, right? Because y is 2 and x is 4. So 2 times 4 is 8 minus 6 equals 2. And in fact, that does check out. 2 equals 2. So my solution to this is 4, 2. I want to go back and solve this equation too. So let's do the other method. Okay. All right, so what I'm going to do now, class, is erase these bottom steps so that I have room for the next thing. So go ahead right now and scroll up to right here. Pause the video and write these steps down on the previous page where it says steps for solving by substitution. So write these 5 steps down. Solve one equation for either variable, plug back into the other equation, solve for the remaining variable, plug back in to find the other solution, and then check. Okay? Ooh. All right. Let's go right here. I don't like how crooked that line is. All right, let's look at the next step. Now, with elimination or addition, you want to multiply one of these equations. First step is to line up your variables. So you want to have x over x's, y's over y's. You want to have everything on the same side of the equation. So you don't want to have y over here. You want to have everything nice and lined up. Notice I have x's, y's, and then my constants are on the other side of the equal sign. Really, I can move my constants over. It doesn't matter. You just want to make sure you have everything lined up. 2, multiply one equation, not both of them, just one, by a value to get canceling. Okay? So this is really nice because 4 and 2, it's easy to see what I need to multiply to get canceling. 3 and 6 makes it pretty easy. 6 and 2. And of course this one's not going to have a solution. This one's going to have infinite solutions. So this is is a bad example because when I multiply this by negative 2, and I multiply everything by negative 2, you get 4x. I'm going to rewrite the first one. And then I'm going to do this. So negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6y. And negative 6 times 12 is negative 12. So now when I add these two things together, so step 3 is add equations together. So now I get 4x minus 4x is 0, 6y plus 6y is plus 0 equals 0. So these two lines are actually right on top of each other. So this is a trivial solution. So I'm going to do elimination with the next example. Add equations together. So hopefully what you do is only one variable cancels out. Yeah, only one variable cancels out. So after you add equations together, you back substitute to find other. To find other solution. Okay. So now let's do with this one. So I'm going to do this one using elimination. So I'm not really going to worry about this part. What I'm going to do is multiply this bottom one by the opposite of negative 2, which is positive 2. So now 2 times x, so let me rewrite my first equation. Negative 2x plus 3y equals 6. 2 times x is 2x. 2 times negative 3 halves, the 2's cancel. I'm left with negative 3y. And 3 times 2 equals 6. So now let's combine them. So you get 0 plus 0 equals 12. Notice the difference between these two values. This one gives us a true statement. So this is infinite solutions. This one, so these two lines are on top of each other. This one gives us a false statement, 0 equals 12. That is not true. So this one has no solutions. These are parallel lines. How do we decide which method is better? Whichever is easiest. Always, whichever is easiest. So for me, if I have a system where one of the variables has already been solved for, I'm going to use substitution. If I have a system where it looks like it'll be easy to do canceling because 4 and 2 have something common, 6 and 3, then I'm going to use elimination. Okay, so now let's do another example. Let's jump back to this one and see if we can solve it. All right. So now, neither one of these are solved for a variable, so I'd have to do some work to solve for one of them. But I do, 3 and 2 aren't really, they don't have anything in common, but 6 and 3 do. So I'm going to use elimination to solve this system. And my guess here is somewhere between -8 ... and between 3 and 4, so 3 ... So somewhere 8 point something and -8 point something and 3 point something looks like my solution. Let's see if we get it. So now I'm going to take these two equations, I'm going to multiply this bottom one by -2. The reason I do that is so I'm going to get a -6 here, so my y's will cancel. So I'm going to rewrite the first equation right here, so I get 3x plus 6y equals -7 halves, where you could say -7 halves equals exactly -3.5. So in this case, you can write the decimal, but if I would have had something else, maybe 7/3 or some other decimal, you don't want to write the decimal, you want to keep it the equation. So here you could write -3.5, which is fine. So now I'm going to do this. So -2 times 2x is -4x. -2 times 3 is -6y equals -2 times -6 is +12, where 12 is equal to 24 over 2, so that when I combine these two, I already have common denominators. So now let's add them together. So now we're doing step 2. We're adding the equations. So 3x minus 4x is negative x. 6y minus 6y is 0. So we'll just put plus 0 equals 24 halves minus 7 halves is 17 halves. So this implies that negative x equals 17 halves. Then I multiply both sides by negative 1 to get rid of that negative, or divide by negative 1, it's the same thing. So that implies that x equals negative 17 halves, which equals negative 8.5. So that does go into my estimate. Thought it was going to be between negative 8 and negative 9, and in fact it was. So my solution is negative 8.5, but I'm not done yet. What I still need to do is find the y value. So I need to plug negative 8.5 back into either equation and solve for y. So since it's a half, it has a negative 8.5 already. Doesn't really matter which one I plug it into. All right. I'm going to plug it back into the second equation. So I know x is negative 8.5, so I have 2 times negative 8.5 plus 3y equals negative 6. So all I've done is I've taken negative 8.5, which I know is my x value, and plugged it into this equation. All right? So now this implies that 2 times negative 8.5 is negative 17 plus 3y minus 6 equals negative 6. So I'm going to add 17 to both sides. And that implies that 3y equals 11. Dividing by 3, y equals 11 thirds, which is approximately 3.67, which does fall into my estimate. But 11 thirds is a much better answer than this decimal that you had to round. So I'm not going to call it that. I'm going to call it 11 thirds. 11 thirds. And I could have done it the other way. I could have multiplied to cancel the x's, but I would have had to multiply this one by another value, right? This one by 2 and this one by negative 3, so that I would have got 6's to cancel out. So this example is probably as difficult as it gets for solving systems of equations. Okay, because there was fractions, I had to go through every single step. So step 1 was doing this. Step 2 was adding them, right? This was step 2, this was step 1, and then back substituting was step 2. Okay? So that essentially is systems of equations. Now let's go look at your homework real quick, because your homework is due 6/27 at midnight. Let's go in here and click on it. So it's right here, systems of linear equations. And it says you have a prereq, but since I'm the instructor, I can bypass it. You can't. And go to question 1. And then here it pops up. So your homework has 8 questions. This says solve by graphing. You don't necessarily have to solve it by graphing. I mean, just looking at this, they have equal slopes and different y-intercepts. So right away you should be able to tell me what the solution is, if it exists. Now, to graph using the coordinate grid, you want to click this line, then you're going to click 1 point. So let's graph this one. So I'm going to start at plus 3. So there's plus 3, 0, 3, and then I'm going to use my slope. So I'm going to go up 2 and over 1. So there's my first line. This one, I would click the line again. And I would go to negative 3, which is right here. And then I'm going to go up 2 and over 1. So there's my 2 lines. I have to grab it, then you would click check answer because I've graphed the lines and it'll tell you. There's 3 that are graphing. There's 3 that are by substitution and 2 by elimination. Now you don't have to use either substitution or elimination. Use whichever one is easiest. These are of course set up to use elimination. So is this one. This one's set up to use substitution. This one's set up more or less to use elimination. But notice here, nothing. This isn't lined up. This is actually set up to use substitution because y has already been solved for. So I could take this 4x plus 26 and plug it back in here. So use whichever one you're more comfortable with. This one's actually set up to use elimination more than substitution. And you do have your view and example, you have your textbook, you have your extra help here, right? And of course, view and example, it steps you through the entire method. The problem's going to be different, but it steps you through all the exact same steps that I just went over. All right? So I'll make one more video and post it tomorrow, and it will cover this last material, the words to symbols, the mixture problems, and the fitting linear models to data. These 2 assignments have a hand-in component. They're not just done in MyMathLab. So I'll show you exactly how I want you to put these values. So question 4, look here, it says, this is complete the MyMathLab portion, then click the print button, complete the by hand portion at the bottom, and turn into your instructor. So really what you can do for the by hand portion is graph it in Excel, and I'll show you how to do that. All right? These 3 problems are just questions in MyMathLab. So this problem you have to fill in, you have to answer the questions, and then I want you to turn a graph in to me. And I'll show you how to construct that graph. It's real simple. Make it in Excel, save it, send it to me via email. And then this other equation, this fitting linear models to data, is all Excel stuff. Choose the correct Excel regression line. So in the next video, I'll show you how to do all this stuff. All right? That'll be posted tomorrow. So I will post this video to our Google Plus circle here in a little bit. And then starting tomorrow, we will start right here with the last lesson from Unit 2. Thank you, everyone, and have a wonderful day.